This section is one of my favorite topics in probability. It's about random sums of independent random variables. In the previous sections, we did talk about sums of independent random variables, but the number of terms in the sum, typically we called it little n, was a fixed number. It might be 10 or 100, but it wasn't a random number. Here we generalize this idea to look at random numbers of terms in the summation of random variables. If you're pressed for time, perhaps it's the night before the final exam, you should skip this section because it's not going to be tested. But if you're interested, I'll say a few brief words uh, and then you can read the textbook to learn more. Problems with random sums are all the same. For some reason, you're adding up random variables, and the number of random variables you'll add up is also random. So here's a good example. You count the number of people arriving on buses during 1 minute. And the thing is that the number of people on each bus, say the ith bus is ki, that's a random variable. But also the number of buses that arrive at the bus stop n is also a random variable. So the sum of the total number of people that arrive are the number of people on the first bus, the number of people on the second bus, all the way up to the nth bus. But in fact, exactly how many buses there'll be is unknown. This is what we call a random sum of random variables. Here's the main result of the section. If the xi are IID random variables, each one with MGF phi x of s, and n is a non-integer, a non-negative integer valued random variable for the count, and this n is independent of the xi's, then the random sum of x1 through x random n has a simple moment generating function. If n has moment generating function phi n of s, and of course the xi's have moment generating functions phi x of s, then the sum, the random sum, has moment generating function phi r of s, which is the composition of the moment generating functions. The rest of this section uses this result in several different applications and also uses this result to derive relatively simple formulas for the expected value of R and the variance of R, the random sum. However, since I promised you I wouldn't test you on this material, we'll stop here and interested readers can go on, either to read the book or to at least to look through the rest of the slides.